Hello students, in this video class we'll see how to obtain a regular expression from the given finite state machine. Right, conversion of finite state machine to regular expression. Right, this is the question. Build a RE from the following FSM. FSM is given and you have to obtain the RE, regular expression. Right, so here we have some rules to be followed. I'll tell all the rules first, then I'll start the sum. First, you have to check whether any states are unreachable. Right, so in your FSM, check any states are unreachable. What do you mean by unreachable? Right, it is not reached from the start state. We'll check. This is my start state. Now check, can I reach this state 2? I can reach state 2. See, I am starting from start state. From 1, there is a transition to 2. Right? When state 1 takes a input, it is moving to 2. So I can reach 2. Similarly, from start state, I can reach my state 3 also. Right? Start to 2, then from 2 there is a transition to 3, so I can reach my state 3 also. So in this question there is no unreachable state. So in this type of sum, the first step what you have to do is like you have to check whether there is any not reachable state, any unreachable state. Right, next is you have to check whether the start state has any incoming edge. Right, start state has incoming edge. You check, this is your start state. Right, start state has 2 incoming edges. Right, from 2 there is an incoming edge to start state 1. From 3 there is an incoming edge to 1. So start state has incoming edge. If start state has incoming edge, what you have to do is like you have to make a new start state, right, with epsilon transition. Right, so I have incoming edge to my start state. So what I'll be doing is like, right, I'll remove this old start state and I'll make a new start state. How I'll make a new start state? Right, I'll take this state, right, so I'll number as 0. Right, now this is my start state, this won't be my start state. Right, and connect this old start state and new start state. Which is your old start state? Old start state is 1. And this is old start state, this is new start state, and both should be connected with an epsilon transition. Connect with an epsilon transition. What is our condition? Start state should not have any incoming edge. If it has incoming edge, right, I have to make a new start state. Right, so while connecting this old start state and new start state, you have to be very careful. You have to connect like this. You cannot connect in reverse way. If you connect in reverse way, again your new start state will have an incoming edge. Right, why I am making a new start state? Right, to avoid the incoming edge. So connection should be from new start state to old start state. Right, it should be an outgoing edge. It cannot be an incoming edge. You have to connect like this. Rest everything remains same. Right, 2, right, 2 is final state. Here 1 is also final state. Right, here it is an A, B, right, rest everything remains same. Right, this is my step 1. Next, step 2. First I have checked whether there is any unreachable state. Then I have checked whether start state has an incoming edge. Right. Now I have to check whether my FSM has more than one final state. Right. Here you check my FSM has more than one final state. How many final states are there? 2 final states are there. In that case also I have to make a single final state. I cannot have more than one final state. If I have more than one final state, connect all the final states, make a new final state and connect all the old final state to the new final state. Right, at the end I should have only one final state. Right, and moreover you have to check whether this final state has any outgoing edge. Right, for start state you have to check whether there is any incoming edge. For final state you have to check whether there is any outgoing edge. Now we can check. Right, this is my step 1. Check here if final state has any outgoing edge. If final state has any outgoing edge. So this is my final state. There is an outgoing edge. Here this is another final state. It has an outgoing edge. So in that case also you have to make a new final state and connect the old and the new final state with epsilon transition. Right. So I'll do this. 0 epsilon, sorry, okay. So these 1 and 2 are my old final state. Right, so this will not be my final state. I'll make a new final state. I'll make this as state 4. Right, connect this new and old final states. Right, connect this new and old final state. Right, now how the connection should be? For final state we have checked whether final state has any outgoing edge. Right, so it should not have any outgoing edge. In that case, what is the meaning? It can have incoming edge. So I should connect like this, incoming edge. For start state, check whether there is any incoming edge. It should not have incoming edge. So we'll connect like this, outgoing edge. For final state, I have to check whether there is any outgoing edge. It should not have outgoing edge. So while connecting, I'll make that as incoming edge. So what should I write here? Connection is made with epsilon transitions. Right, now I have to convert this FSM to RE. Right, the initial steps are over. Unreachable states I have checked. In start state and final states I have checked, and I have added the new start state and new final state. Now the next step is one by one state you have to remove. Right, you have to remove one by one state. Right, so while removing, right, leave the start state and final state. In between states, one by one you have to remove. So this is my start state, this is my final state now. So in between I have 3 states. This 3 states I have to remove it one by one. Right, first I'll try to remove this state 3. Right, state 3 I am removing. You check. This state 2 is connected with state 1 through 3. I have a connection like this. So if I want to remove this, right, if I want to remove this state, right, how the connection will be? I am removing this state. So state 2 to 3 and 3 is connected to 1. So if I remove this 3, directly I should connect 2 and 1. 2 and 1. And you all know this self loop what is the corresponding representation? It is A star. Right? Star operator is the pictorial representation of star operator is self loop. Now I'll remove this, and if I remove, how I'll get it? Epsilon B. I am going to remove state 3. So how should I write? You check, state 2 is connected to state 1 through 3. Right? It starts like this. So since it is starting like this, first I should consider this A. Right? So how will I write? A star, B. Right? So 2 is connected to 1. What should I write here? A star, B. A star, B. Right? Rest everything remains same. So it is 4 here, and epsilon here also it is epsilon. I have written everything. Right? Epsilon A, B, it is A star, B. Yeah. Right? This is my step 3. Now I will try to remove this state 2. I will try to remove my state 2. So step 4. Step 4, I will try to remove state 2. Now you check state 2. If I remove this state 2, right, this state 2 has 3 outgoing edges and 1 incoming edge. Right? Out of this 3 outgoing edges, 2 outgoing edges going to state 1. Right? So I can go to state 1 from 2 either through B or through A star, B. I'll tell once again. From state 2 I can go to state 1 through B or A star, B. Or, right, since it has 2 branches, it is or. So if it is or, in regular expression, which operator has to be used? I have to use plus. Right? So what I will do? Now I will this 2 outgoing edges I will make to single using which operator? Plus operator. And so it is 0 epsilon 1 2 A. What should I write here? B or A star, B. Correct? Then my final state. Right? And this connection, these connections. Right? Now you check, what is my aim now? I have to remove my state 2. I have to remove my state 2. So if I remove my state 2, again see I have 2 outgoing edges and I have an incoming edge. You check this connection. 1 from 1 there is a connection to 2 and again one more connection to 1. So what is the meaning of this starting from A and ending to A? Starting from A and ending in A. So instead of writing like this, can I write like this with a self loop? Starting from A and ending from A. So in that case, what could be my next step? Step 5. Right? So here it is starting from A, right, and ending. So which operator? Just the concatenation operator. Okay, concatenation operator. So it is A, B plus A, just concatenate. B plus A star, B. right? What is this state? 1, right? I have 1 2, these two connections I have written like that, right? So I can this one connection I have written. At the same time, from start state I can reach final state through 2. What is that connection? From start state, start, then 1, then A. See, one more connection is there. One more connection is there, right? One is like this. It is circular connection, right? Another one is A into A dot epsilon. Again, this is also one concatenation. A dot epsilon, right? So here I am going to remove my 2. In that case, this I have to consider. At the same time, I have to consider this, right? Since 2 has 2 outgoing edges, both I have to consider, right? So my 1 is connected to final state, which is my final state, A dot epsilon, which is nothing but A. I'll tell you once again, don't get confused. 2 state has 2 outgoing edges and 1 incoming edge. So both you have to consider. So A and then first outgoing edge, this circular. This how we have written? Self. Starting from A, starting from 1, ending to 1. I have considered like this. Then A dot epsilon, right? 1 is connected to 4 through 2. This I have to consider. While considering this A dot epsilon, it is A. Okay, I have removed 2. Now check, 1 is connected to 4. Here there is one connection. 1 is connected to 4 through an epsilon. Right, this is how I have removed my state 2. Right, now you can check now which state I have to remove. State 1 I have to remove. While removing state 1, you can check here there is a self loop. Self loop means, you know, it is star operator, right? If something like this, how will I write in regular expression? It is A star. So now I have A into B plus A star B. Right, now how I should represent? Whole star while writing the regular expression. Okay, that is one thing you have to take care. And another one is, see, from 1 I can reach final state either through A or through epsilon. When you see branches, you know it is OR operator. OR. So what is the corresponding operator? It is plus. Right, now I'll write this. Step 6. Step 6, it is 0 epsilon. Right. Shall I multiply this? If I multiply, if I take this A inside, it will be AB plus A star B. I have taken this A inside. AB A star B, right? This is 1. Now how I should write this final state? Right, A or B, epsilon or A, right? Now I have to remove this state. If I remove this state, right, how to remove? Start state is connected to final state through state 1. So everything is concatenation. Epsilon in epsilon dot this one dot epsilon plus A, right? So how will you represent? Step 7, it is start state. It is connected to final state. Which is my final state? Just the concatenation, right? So epsilon into, how to write this regular expression? Remember this, right? So it is AB plus 1 2 A star B the whole star, right? again this dot operator, concatenation epsilon plus A. Right, so epsilon concatenated with the whole thing, it is this one. Right, I'll tell you, epsilon dot A is nothing but A. Right, so what will be your final regular expression? It is AB plus A star B the whole star. Right, epsilon plus A. This is your final answer. Thank you.